Okay, so we are going to talk about group zero, the noble gases. And of course, they are found at the far right of the periodic table here, group zero. And all the noble gases have a full outer shell of electrons. So the electronic structure of helium, I've shown here, is just 2 as helium. Neon is 2 and then 8 in the second shell. Argon is 2 and N8 and then 8 in the third shell. You don't need to know the structures of the other noble gases, but they all have full outer shell, and that means that's why they are unreactive. There's no reason for them to react because they have the stable configuration of a full outer shell of electrons. Right, so just a brief word here. This one, OG, Ogner's Sun, this was only discovered in 2002. It's an artificial element. It's made by bombarding 2 atoms together. We don't really know that much about it because only 5 atoms of it have ever been detected. Radon is a radioactive gas. That's why it's got square brackets there, because it exists in quite a lot of different isotopes of it. The others are all found in the Earth's atmosphere in small quantities, except for helium. Helium is not naturally found in the Earth's atmosphere. Any helium that is made, it's so light it can escape the pull of the Earth's gravity, and so it will escape into outer space. But argon, there's about 1% of the Earth's atmosphere is actually argon, and the others, neon, krypton, and xenon, are a lot less abundant than that. Okay. So there's not much to say about the chemistry of them because they don't actually do anything really. Although krypton and xenon, they have compounds. Krypton and xenon have been made compounds with fluorine, the most reactive element in the periodic table, and also with oxygen. But they are unreactive because they've got a full outer shell. Okay, we need to know about some of the trends. So let's have a look at the boiling points. Now you can see the boiling points there are, right, helium has got a very low boiling point. Now the lowest possible temperature, absolute zero, is minus 273 Kelvin, 370 degrees C, sorry. Or that's called 0 Kelvin. A Kelvin scale of temperature. Helium's is very close to that value, minus 269. As you can see, as the atoms get bigger, the boiling point increases, gradually increases. If you plot a graph there, there's a fairly smooth trend relationship between boiling point and the atomic mass of those elements. Just a brief word about the discovery. So the noble gases were only discovered about 1900. Okay, and the first one to be discovered was argon, and that's because it's the most abundant. It makes up about 1% of the Earth's atmosphere. And when argon was discovered, this obviously caused some problems because if you create a new element there and you put that in, that's going to mess up the order of the whole order of the periodic table. So that's going to, for example, that's going to mean bromine is going to go into the next group along. It's going to be in the wrong group. So after argon was discovered, scientists realized fairly quickly that there must be a whole group of elements, which here, one at the end of every period. So that if you have one at the end of every period, it doesn't mess up the order. And so after argon was discovered, they started looking for the other gases, and within a couple of years, they discovered all of them. They're all present in the Earth's atmosphere, except for helium, but in quite small quantities.